Hello, good morning. This lesson is for my Honors Integrated 1 class. This is for 24.2. Before I get started, I want to say I hope everyone's doing okay out there. We have a couple more weeks left and we are done with the semester. So let's finish strong and do everything we need to do. Turn in all the assignments, take the attendance quizzes. Let's make sure we get marked present. I'm going to try and keep this lesson a little light. I think the concept can be taught without going too much in depth. It's really a good review section. We see a lot of old ideas, and I think that it's, like I said, I think it's a good way to review some of the math that we've learned and see some results uh, in our arguments about determining if our four-sided shape is a parallelogram. That's the goal. Is our four-sided shape a parallelogram? So our goals are to understand what conditions are needed to have a parallelogram. All right, and so over here I have three conditions, and here's my fourth condition. And these four conditions, I'll show you how they make a parallelogram. All right, I'm not going to go into the two-column proof version. Again, I'm going to very quickly show you that, how we would make the argument. All right, so let's see here. Let's jump right into this. So again, I want to show you why these three shapes are a parallelogram as well as this fourth shape. And the way that I'm going to get these three four-sided shapes to have parallel opposite sides is I'm going to use this idea of congruent alternate interior angles make parallel lines. When I have congruent alternate interior angles, I get parallel lines. So let me just jump right into this, okay? So my first condition that would make a parallelogram is if I have two pairs of congruent opposite sides. And the way that the argument works is, again, we make congruent triangles. So I draw a vertice. That's not a vertice. I draw a diagonal from the vertex, from one vertex to another. I'm having a hard time with my words. And I've now created two triangles. And in fact, I've created two triangles that are congruent because of side, 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 right? And because I've done that, that means that the parts that are in the same positions themselves must be congruent. So this angle that's made up of the side with the 2 and the 3 marks must be the same as this angle made up by the 2 and the 3. So if I put a little, let's see here, put a mark in here, that means that this side must be parallel to that side. Right? And the angle that's made up by the 1 and the 3 are also parallel. The angle made up by the side of the 1 mark and the 3 mark, and the 1 mark and the 3 mark, they must be congruent, not parallel. And this is another set of alternate interior angles. However, this set is oriented in this way, which would make these vertically oriented sides also parallel. So right here, very quickly, we see that congruent opposite sides make a parallelogram. This is one condition I need. The second problem is this guy. This problem is showing me diagonals that are bisected. And let me walk you through why that shows this. Okay. This is the same as this, so this got bisected. This is the same as this, so that got bisected, right? So this is how I show you in a picture that my diagonals are bisected. Now, I have actually two pairs of congruent triangles, and it's very simple to argue. I have parallel opposite sides. All right, so let's look at this triangle and this little triangle, right? So there's a hidden congruence here, so I have that angle is congruent to that angle because we have vertical angles, and now I have this triangle congruent to this triangle by side angle side, which implies that angles in the same position must also be congruent, right? Corresponding parts of congruent triangles, but now I'm back to congruent alternate interior angles, and so this pair of congruent alternate interior angles implies that this side and this side must be, in fact, parallel. All right, so I've I've argued that I have one set of parallel sides. Let me argue that I have another set of parallel sides with a different color. And what I'm going to do is I'm going to look at this triangle and this triangle. So, so that angle is the same as that. Again, this triangle is the same as that one because of side angle side, which would then imply to me that, you know, angles in the same position must be congruent. So that's going to be congruent to that, and these guys are alternate interior angles for these sides, and since they're equal, that implies that these guys must be parallel. So we've seen that bisected diagonals means that our shape must be a parallelogram. Our third condition is I'm going to have a set of opposite sides that are parallel and congruent. And when I have this condition, I must also have a parallelogram. So I only have to argue that these sides are parallel, and I'm going to get to that by using congruent alternate interior angles again. So let's make this into a triangle because that's what I need. Right? And because these are parallel, that means that I know that this angle must be congruent to that angle, and this side's congruent to itself. So very quickly we get side angle side, side angle side, so the two triangles themselves are congruent. And just like before, parts in the same position must be congruent. So this angle must be congruent to that angle because they're in the same position, and that forces this side to be parallel to this side. So those, these three conditions lead to parallelograms because of this concept. The last one, the way that I want to get my opposite sides to be parallel is I just have to show that these two angles add up to 180 degrees, and then that means that the sides must be parallel, right? So here we have a quadrilateral, and we know that four-sided shapes, the four angles add up to 360 degrees. Right, and so I have angle A, angle B, angle C, angle D. And I labeled it because I was thinking about it. I should walk you through this really quick. I know that the four angles add up to 180 degrees. Right, angle A plus angle B plus angle C plus angle D add up to, not 100. The four angles add up to 360 degrees. Okay. Okay, now angle A and angle C, they're the same. So I'm not going to say angle C anymore. I'm going to say measure of angle A. Because again, right here, they're the same. And I'm going to do that with angle D. I'm not going to say angle D anymore. I'm going to say angle B because these are the same. So I'm not going to say angle D. I'm going to say measure of angle B. Because again, they're the same. Now, I'm going to combine like terms. I have two measures of angle A. And I have two measures of angle B. And these guys together add up to 360 degrees. Now I'm allowed to divide everybody by 2. Which means that the measure of angle A plus the measure of angle B, those add up to 180 degrees. So I have this, these two guys adding to 180 degrees, I have that happening here, right? These two guys add to 180, so these sides are parallel. But remember, angle B is the same as angle D. So that means that these two themselves must also add up to 180 degrees. So then that forces these sides to be parallel, right? So, I mean, again, like I said, I wanted to keep the arguments kind of light, more of an overview than the two-column proof. But I wanted to, again, show you guys what the 4 conditions we need to have in order to have a parallelogram. Okay, so this is the lesson. Again, let's make sure we're doing everything we need to do. Let's do the assignments. Let's take the attendance. And again, let's most importantly, let's have a good day. I will post the next video on Wednesday. And have a good day, everybody.